we shall start. GM Warsaw, my name is Justyna Broniszewska from ETHWarsaw Foundation, and I would like to welcome you to the next meetup. So let's quickly go through our code of conduct. So first of all, be kind and respect others. Second of all, we won't tolerate shilling or sales pitches. So here are our goals. So we would like to educate people about Web3. Additionally, help discover new free Web3 talents and put Warsaw on the map of great Web3 events in the world. And additionally, contribute to the global Ethereum community. And let's quickly take a look at our roadmap. So we had these meetups. We'll have additional meetup in July, and then we'll have a conference and hackathon in September. So feel free to join us there. And I'm organizing it with the great team. They are somewhere here, so if you have any questions, just reach out to them. They will be happy to answer any questions you have. So I'm also very happy to tell you that today's meetup sponsor is Ethereum Foundation, and we are on the Ethereum Foundation's road to DevCon. So without further ado, let's go through agenda for today. So we'll have first speaker, that is Tomek Kolinko, and he will tell us about wild things he learned from the compiling Ethereum smart contracts. And the second speaker is Rafael Cosman, and he will tell us about future of lending in DeFi. So I hope you are as excited as I am about these presentations. And after these presentations, we'll have pizza, beer, and networking. So please enjoy the meetup. If you have any questions, just reach us on Telegram, on Twitter, or our page. So thank you. Please welcome Tomek on the stage. Tomek, the floor is yours.
Thank you. One moment to set up, and I'll be with you. Right. Hello, hello. All right. The microphone is working, and let's see if the presentation will be working too. All right. Awesome. Hello, everyone. I'm Tomek. I've been to the blockchain community since 2012 or 13, so that's like a long time. I'm like a dinosaur here, I guess. And I remember the beginnings and everything else, but a few years ago, I was tired after my previous project, and I broke up with my girlfriend, and I built a project out of anger and everything else. So, you hear a lot of, about a lot of projects made from passion, and this one was not one of them. I wanted to decompile all the contracts on the blockchain network, and, if you're not an angry person, there are other reasons why you would want to do so. And those reasons are, first of all, curiosity. So, if you're able to, there's millions of contracts on the blockchain, on Ethereum blockchain, and pure curiosity makes us ask ourselves, like, what do they do? What do all those contracts do, right? Because we know a few of them, but all of them, like, what do they do? Second thing is, it's easy to browse all the transactions from the blockchain, right? You go onto Etherscan, or you download your own Ethereum node, and you get to see all the transactions. So you can see which address sent money to which other contract. But transactions are way more than that. They are function calls of other contracts and whatnot. And really, if you want to understand what's happening on the Ethereum blockchain, you need to understand what contracts are doing. The third thing why it's worth to analyze all the smart contracts, there is this dream that if you would understand what every single contract does, you could build this machine that just analyzes all the faults or all the possibilities and build like a theorem prover, mathematical function that you put in a question like how can I earn more money? And it shows you how you can do that by calling various function calls, right? So I don't know how many of you are familiar with formal methods in mathematics. This is Warsaw Polytechnic, so perhaps some of you know. How many of you? Okay, some of you. So if you analyze a mathematical theorem, you can figure out what are the flows in it, or you can make sure that it's correct, right? And by using the same methods, you could analyze the blockchain if you understood how contracts work, and figure out what are all the faults and how to earn money on the blockchain and whatnot. And that's kind of an interesting challenge to do. And other things. I won't go into that right now, but I will tell you later on. Also, apologies, my English may be a little bit rusty because the last 2 years of the pandemic I didn't get a chance to travel a lot, but I hope it will get better as I continue with the presentation. Anyway, it's hard to analyze contracts, and the reason behind it is that only seriously like 1% of contracts have their source codes published. Like it's 99% of the contracts that had ICOs and that have actual users, but 99%, and that's an actual real statistic, never publish their source code. So if you go into any random contract on EtherScan, like truly random, chances are it will not have a source code. And if you want to analyze how the whole network operates, like you will not see the codes for those contracts anywhere. Now, 95% of the contracts that have their sources published are, in Solidity, the most common language, which, in my opinion, sucks when it comes to analysis of the contract and doing any kind of software auditing and anything else. Every single version of Solidity has some changes. So if you want to use a machine to understand what the contract does in Solidity, like good luck with that. Like it has been different 2 years ago. A different version of Solidity was there 4 years ago, and tiny changes that happened in the meantime will make it very hard to do software analysis of the contracts. And then third case is Solidity is really, really bad when it comes to readability. So if you want to analyze the contract, it is a terrible language, and I will prove that to you. If someone thinks differently, I will prove that to you in just a few moments. So, but first I want to explain what I did, I think 3 or 4 years ago, and what I spent two years building. It's my own website, and the source code is public, so it's not shilling, I guess. It's called ETHWarsaw.org. You go there, you type in the address of any contract, and it decompiles that contract. The tool hasn't been updated in 2 years, so I apologize in advance if it doesn't work for every single contract, and even then it broke for some of them. But for many, if not most contracts, it worked quite surprisingly well. So you type it there, you typed in the address of the contract, and then you get to see the source code, which is not Solidity, because I'm a Python person, so yeah, I hate Solidity. So this is a smart contract of CryptoKitties, one of the first NFTs out there, and if you can see, it is pretty readable. And before EVM, when people thought about the compilation of contracts, it was never this kind of quality, and it rarely ever is. So you can actually browse the contract, and it is readable for humans very, very easily, and sometimes it's even better than Solidity. Now, the proof that Solidity is bad. By the way, who here likes Solidity? Or who knows Solidity here? Okay, who knows Solidity? Not likes. Okay, so you will get it. So this is a piece of code from one of the tokens, and it is terribly bad. It will make you lose, like this token failed soon after launch, I think, and it has a terrible flow, and like it doesn't work. Like you can cheat it super easily. And the question is, this is just a few lines of code, and there is a terrible bug there that allows you to do whatever you want with the contract. And the question is, can anyone find the bug? And I know that you may not see that properly, and I apologize to the camera person, but I will walk here. Oh yeah, the camera person is here. So anyone? Can anyone see the code? I know that it's difficult during the presentation, but can anyone find the bug here? I regret not bringing a cookie here because the idea was to give a cookie as an award. But I can buy an NFT to anyone, like an NFT of your choice, below $5. If you can find a bug here. Okay, I will give you a minute. No? Okay, this is like this doesn't work at all. Okay, the idea here is this assert here should be assert and open bracket, close bracket. Without that, the whole assertion doesn't work because it's not a function call, it's just screaming assert, but not saying that it should fail or whatever. So it has no function whatsoever. Because of that, this doesn't work. Because of that, this doesn't work. And because of that, the whole transfer over there, you see save, oh, it saves up, it should be safe at, but yeah. There are no checks here, checking that the person that sends the tokens actually has the tokens on their account. And it compiled with no issue whatsoever on Solidity and no warnings even, at least at that time, right? Because you miss here 2 brackets. So one thing is it compiled. The second thing is it's almost impossible to find because of the language. And really, like, you can design a better language that will not allow you to do these kind of things. So yeah, like, this is a simple example, and I've shown it to multiple auditors, and they couldn't spot it. You know, people that professionally do code audits couldn't spot this kind of a bug. And yeah, that's bad for the security of the whole ecosystem, I would say. Anyway, I will show you this function, or a similar one decompiled, and then okay, yeah. Perhaps something changed in the last 2 years.
Yeah. But in Python, it was also like pass without a warning. Like, you can also just
actually no, I don't think so. You cannot no, because it's a function call, and then Python will say no, it's not a function call. You're not allowed to do that.
But like, for example, one is a valid Python code, right? Like,
no, it's a valid Python expression, but you cannot type in one in a line and nothing else. Okay, I may be wrong. You may be wrong. We can you can check and get back to us in a second, because I'm quite sure you cannot do that in Python. You can do that in JavaScript, but and in C you can do anything in C. So, the better way to show that. Did you find the solution? Did you launch the Python? It works? All right. Okay, sorry, I stand corrected. It shouldn't. All right. Okay, in a console or in a code? In a console it may, but I'm not sure if you can launch Python with that code. But anyway, yeah, perhaps if you manage to do that, just scream out loud, I was wrong, or you were wrong, or, you can't handle the truth. Anyway, so I will show you the same piece of code decompiled. And this, it's here. It's not about the language even, but it's about the compilation that just wraps it up and puts it out as a single function. And here you can see the difference between the checks and the checks being performed and the checks not being performed. And this is the actual output from the decompiler. So when I first saw with one of the contracts that there are no checks performed, I checked the sources and I saw that there are checks, exactly that code. I spent like a day or two debugging the decompiler, because the decompiler told me, hey, like, there are no checks here. And I look at Solidity and I try to figure out, I can see checks here, right? And I had to debug everything. And turned out, yeah, like, the decompiler, from its perspective, nothing happened in those functions. So it didn't add them to the code here, because why not? Like, there was some code, but it did nothing from its perspective. So yeah. And this is one of the benefits of the compilation. Like, you get to see source codes of smart contracts from a different perspective, and then you can use it to do as a part of software audit and see if there are some things that you don't see in the original source code, but you see here. And that was quite awesome. But then it gets better. This is one part of the decompiler that provides the human-readable form. And then there is the different one that provides, you could say, a JSON form. So, but it's not connect. But wrong. Yeah, sorry, camera person. So here you can see the same thing, but with but just in a machine-readable form that is super easy to analyze, right? Exactly the same ifs and whatnot. The benefit of this form is that we can easily browse, so we can have whole contracts made out of this form, and we can easily analyze the code using a simple piece of code in Python or any other language. So above we can see a function, and below we can see a very simple Python code that is analyzing this code, trying to find exactly the kind of bug that happened before, that I explained before. And to my Python friend, which I think may enjoy it, like, look at this, and this is really Python. And try to embed that in the Python. Anyway, so this function below is a true Python, and it can analyze all the contracts that are provided in this form and provide us with an answer, basically if that kind of bug exists in the contract. Now there is another interesting class of bugs in the contract. You know the function self-destruct? How many of you? Solidity writers, contract writers? Some of you? Right, so self-destruct function is this function that destroys the whole contract, all the money in it. Well, it sends all the money to some account, and basically, kills the contract. Right? There used to be a bug in one of the contracts, in parity contract, where anyone could call a self-destruct function and just destroy the whole thing. And people lost like millions of dollars a few years ago because they didn't notice that the function was not protected by anything. Right? Like somehow it slipped through the beautiful Solidity code, and just anyone could call a function that destroyed the contract, right? And people's money along with it. It was interesting because someone noticed that and pushed that as an issue, public issue on the GitHub repo of the project, and then someone else said, "Oh, I checked it. Yes, it works," and just threw the contract, and millions, or if not hundreds of millions of dollars, got lost. Right? So it was fun times. Anyway, there are more contracts like this because I decompiled all the contracts and then built a simple function that found a lot of contracts that just have self-destruct functions. Sometimes not protected by anything. Sometimes it was out of malice because someone wanted to destroy contract and just wanted to mix up the source code so that no one would see it, and then say, "Oh, it was an accident. The money got sent somewhere." Sometimes it was a mistake, and sometimes it was legit contracts that just wanted to get destroyed after some time, and they didn't care who called the contract, just as long as someone called it, right? So here are 2 out of, I think, 600 contracts that I found on the blockchain that anyone can call and just destroy at any moment. Right? It was a few years ago when I did that, and yeah, the contracts existed, and some of them had money, and some of them could be exploited actually, like very little money, because the ones with more money already got hacked. But yeah, like I have this idea of a hackathon project, and feel free to try it. Use the decompiled source codes, and then during the demo say, "Oh, here is this function that kills all the contracts that can be killed," and then press enter as you see the mayhem happening, behind your back. It will be an awesome presentation, and I think someone should do that. I won't do that, but someone else. Or another idea for a cool hackathon project: find all the contracts that can have their admin or owner changed, because also a ton of them, and then mix them up, like shuffle the owners of all the contracts that can have that changed. Like this is some crazy stuff that you can do when you have the access to the data. And actually, when I decompiled all the stuff, and I'm very much pro open source, I pushed it to this cool database called BigQuery. And BigQuery is a database from Google. This slide won't tell you much about the database, but the idea is I pushed like 2 or 3 million contracts, which was all of them from Ethereum network, to the database. And BigQuery as a database has one cool thing. It allows you to create search functions. So it's like an SQL, but with one addition. You can select from the database using a JavaScript function. So what you can do is you can write a JavaScript function that finds all the contracts that have bugs in them, and just use it through, push it through BigQuery, and in 20 seconds you will have like a list of contracts that have the bug, which is quite awesome because then you can play with them and whatnot, right? So yeah, this is the output of one of the searches, and that's just one page because there are like 500 contracts there. And the other cool thing is that it's not just about you finding the contracts, it already gives you the decompiled version of the functions, so you can see how the functions perform and whatnot. And you know, you get to see into everything that is happening and or could be happening on the Ethereum network through that. And you know why it's important to do that? Well, you know, someone actually printed some tokens from one of the contracts. And you know, if someone built a tool that would search for that and exploit contracts as soon as they were exploitable, we would have way fewer hacks because you know the contracts would get destroyed the moment someone published some wrong piece of code before people put money into it. Otherwise, we have situations like this: someone printing free tokens because they could, and of course the drama that ensues after that. You know, it's a GitHub issue saying you can stop trading on our stock exchange. Contract was hacked and whatnot. So yeah, like people should have better visibility into the network. Another cool case is Constantinople network upgrade. So Constantinople was one of the versions of Ethereum protocol, and they changed one thing in the virtual machine. And a week before premiere, it turned out that some contracts could be broken because of that. The question was which ones and how big is the issue. And we actually had to use the decompiler and that search that you just saw to weed out all the contracts that could be exploited by that could fail after the network upgrade. So the idea is that, you know, if there is a network upgrade, if we change anything in the virtual machine, we should check all the contracts if they can be exploited. And you know, that's the idea. That's one of the cool things that you can do with that. So the code for the search is available on GitHub. So it's called Asterix, and feel free to play with it. I cannot promise that it still works 100% right because it was 2 years ago the last time I tried it. But yeah, you know, if it works, enjoy and have fun. Another fun story is that 20 seconds that it takes for BigQuery to search through the contracts. That's a lot of time. I'm not a patient person. 20 seconds? No, like I want it faster, right? I don't have screenshots of that, but the thing that I built on one hackathon was quite cool because I went down to I think 100 milliseconds or 50 milliseconds. So essentially, we put all the smart contracts on Redis RAM disk just into the memory. So it took like 200 gigabytes of memory, and indexed it all. And you could type in the bug patterns in contracts, and you would see instantly if the contracts had bugs, and just like Google Instant. So you type in things and you see the pages. That was the same for the smart contracts. That was quite awesome because then you can just you don't have anything better to do. You just sit down in front of the laptop, you chill, and you try to figure out all the patterns that could break the contract, and instantly you can play with that and see all the faulty contracts on the network, which was quite awesome. So right now there is no source code for that super fast search available, but you can build it. It took me 2 days or 3 days. That's another awesome idea for a hackathon. Now, a few other things that you can use the compilation for. One thing is of course EtherScan. So not all the codes are public, and if you click decompile smart source code, you will actually see the output of the decompiler over there on EtherScan right now, which is quite nice, especially because EtherScan added that after I kind of retired from the blockchain community, and I told them, oh, I will not be updating that, and they still added the code here. Another thing is what we built during one of the hackathons, I think in Singapore. It took us 1 or 2 days using the machine-readable form, a project called Show Me What You Got, like from Rick and Morty. So the idea was that you type in the contract identifier, contract address, and it shows you all the accounts associated with it. So all the owner accounts, all the other accounts that give you access to certain functions, and it shows you what kind of functions can change that. So in this case, for example, for CryptoKitties contract, you know, you have CEO address, you have CFO address, and then you can see which functions can be called by the CFO, which functions can be called by CFO or CEO. CFO can receive money through this function, and then you can browse the function and see what it's doing and under what conditions. And also, it shows you which function can change the CFO. So here we can see that there is a function called setCFO that can change it. And it's a very nice way to browse contracts. And there is, you know, there is no, like there is, I would say, no other generic way to do that right now than by finding this code and executing it. So that code is also available publicly on GitHub. Another interesting thing that you can do with decompiled smart contracts, you know, you have transaction details. So EtherScan shows you a transaction. And if you ever try to figure out what's going on, you end up with something like this. You have the function transfer. Okay, that's nice. You know the name of the function. You have no idea what this transaction actually did, right? So, that's not good enough. We can do better. And there was a proof of concept that I built some time ago, and it shows it in a more readable form. So it's the same transfer function. You can see parameters nicely, not just some hex code. Then you can see that there is this transfer function. You can go line by line and analyze what it did, and you can see the storage value that gets changed by this function. And this is super nice and readable for people that have any kind of technical skills. To, you know, this makes things way easier when it comes to analyzing transactions. So this actually, sadly no source code survived for this kind of demo, but again, it takes 1 day to build once you have the source codes. All right, so that was more or less what I found, what I learned, and what I think are the possibilities from the decompiled smart contracts. I have some more things that I could talk about, like details of the smart contract decompiler, how to build one and whatnot, but I'm curious if there are any other questions. And if our friend over there checked if I was right or he was right, because you didn't scream, so I guess.
I mean, I didn't want to interrupt you, but...
Okay, so it works. I was wrong. Apologies for that. Yeah. So anyway, questions. Anything that you can ask about smart contracts, about building the decompilers, about how the network operates, I'm open to answer. All right? So the question is, can you compile it again after the decompilation? That's a totally different challenge. One thing is to decompile so you can understand it. Another thing is to decompile it so you can recompile it again. And sadly, my decompiler cannot do it, but it's open source. Someone can add it. So yeah. Yeah?
You have a mistake in your presentation. It's 2022.
Today is 22. Oh, no, I had a meeting now. I have to go. Thank you.
So what is the total value locked in all these contracts that are broken?
Can you repeat?
What is the total value locked in all these contracts that you found that have mistakes?
So I didn't spend like a year trying to figure out all that. So just low-hanging fruits, it wasn't much. It was like hundreds of contracts, but actually the amount of money was, you know, a few $100s perhaps. So it wasn't much. Although it was, again, 2 years ago, so now it may be better because I don't think anyone built a good tool since that time. And again, we just checked all the low-hanging fruits. So like 2 or 3 or 4 basic searches. And if we could find that in one afternoon, then, you know, writing a better crawler, I think, you know, it can be, I would say, not millions perhaps, but tens of thousands of dollars. I think it's there for anyone to just grab. Hopefully, you know, without you know, the funny story is, I spoke to the people from well, you know, way up top in the community. I don't want to mention the organizations there, but you know, we discussed that, and the idea is, you know, if we give better tools to hackers, and if we break contracts the moment there is $10 on them, it's better because it's better for the contract to have those $10 stolen than for the contract to not get exploited until there is 10,000 or $10 million there, and someone finally finding time to hack it properly, right? So if we would have better tools, ideally the ones that are just automatically hacking everything that can be hacked on the network, it would make the whole network secure. And then, of course, some contracts would get a little bit of money lost. But I think, if you manage to steal, a few $100 from a token, you did everyone a service. I don't think anyone will chase you. Above 10,000, I would, or 100,000, I would just report it to the owners of the contract. The other thing that I noticed, for example, and I will give you, I found some contracts that were obviously backdoored. And, it was no point, there was no point to report that to the owners because they clearly knew that. Few, at least one or two. And they were just waiting for the stakes to get higher and run away with money. And in this case, what you should do is steal the money and give it back to the people at least, right? If it's enough. If it's below 1,000, just, keep it. No one cares. You were first. Well, your argument is that it's not stealing and it's reading the contract correctly. I would say it holds on Ethereum Classic because they are code slow kind of people, right? So on Ethereum Classic, totally you can do that. It's like that's their selling point. On Ethereum, it's like code is code, law is law, and it's complicated, right?
It's very cool that you found out that you can actually decompile Solidity. But it feels like somewhat of, an inefficient process to have to write in Solidity and then decompile. Instead, how about revising Solidity or releasing a language that would maybe be compilable to Solidity and have people write in that language instead?
That's a good point. So first of all, it's not just from Solidity. So it doesn't have to be Solidity. It can be any language, right? There are some pieces of code that are difficult to break and the compiler will fail, but it decompiles Viper as well as Solidity as well as any other language and even contracts that are written in pure assembly into a human readable form. So I had someone tell me, hey, I just read this contract because the original was like part assembly, part something, and this one was clearer, right? So it doesn't have to be that way. Now with Solidity, I knew that there was work being done on some intermediate form of the language, so we can analyze it. Yeah, not going through the whole cycle, and so I knew there was research into that. I don't know where it's at right now. And at least 2 years ago, there was a lot of talk about various other new languages. But the thing is, and people develop them, so there are other languages there that are better, where it's harder to make mistakes, of this magnitude at least. But now, the challenge is that other languages right now, it's hard to get traction because you have so much documentation, so many developers knowing it, and so many developer tools that if another language comes, and they do sometimes, it's harder to use that language. And so this network effect right now, is pushing very much into Solidity, right? Still, Solidity could be improved. At least the last time I checked, I actually never compiled anything in Solidity. I only decompiled it, but that's another fun story. But hope it's an important piece of subject.
So I got a question about this tool. So you find a certain contract. You type it to Etherscan. So when you're there on Etherscan, you can connect through the API and, for example, change the owner to yourself.
So first you decompile the contract, right? And you can do that through Etherscan. You can download the tool to your own device and do it manually.
Yeah, but I mean on Etherscan,
if you find a flow in the contract that allows anyone to change the owner, you can go to Etherscan or any other way and just call a function and change the owner to yourself. Yeah, but you need to know which contracts have that bug there, right? But yeah, is that the answer to the question?
Yeah, because I thought that the source code need to be on EtherScan to connect to the ABI, because without it you won't got it.
Yeah. You're absolutely right. There needs to be an ABI for EtherScan to use it. But then, for example, if you go to evim.org, it will automatically generate ABI, if I remember correctly. So you can get an ABI, then upload it to a client and just call it directly. And you don't need an ABI to interact with contracts, but it makes things way easier, and you can use default tools.
Yeah, one more thing is that you got this website when you typed the specific address of the contract, and you told about creating a JavaScript function to find other contracts with some bugs. And can you talk more about it?
It's okay. In a moment, because I can see 2 other questions, and this will be a long answer. All right. I saw a question here, and the next one.
I can talk to this device. So, as we were mentioning, EtherScan, what do you think about like contacting EtherScan team and like including your analyzing tool? Because EtherScan is really popular tool, and like it could like show the contracts that could be easily exploitable or have backdoors.
Yeah, so I spoke to the people from EtherScan. The thing is, and they embedded my decompiler over there, so they know the tool. They run it themselves. The thing is, you need some technical knowledge, and you need to figure out how things work. And I guess it wasn't too high on the list of priorities. And for me, open sourcing the whole thing, that was like my gift to the community. And now I said, okay, let other people start doing things with it. Sadly, like not many people did it, so that's why I'm talking here to say, hey, you can do this cool stuff, right? But yeah, like different priorities for them, I guess. So yeah.
So I also have a question, but first of all, I'd like to return credit. So even though one is correct Python code, assert is not, because assert is not a function, it's a keyword, so your original claim was correct. But it would not work with any function, but with assert, yeah.
So I guess you're still correct, because with other functions...
Okay, but back to the question. So how would you describe the difficulty of writing a decompiler? Like you said that you've never compiled Solidity, so I guess it must be easier than I think. For example, is it easier to write a decompiler than compiler?
It was a dark year for me building the decompiler, right? No, like it came out of curiosity, you could say. Like I opened up the bytecode of CryptoKitties code. I saw the assembly there, and I said, "How hard can it be to build a decompiler for this? This is assembly. Like let's just wrap it up, right, and decompile it." And actually, I had some decent results after a week or 2. But just pure assembly, yeah. But then I got into loops and trying to figure out all how go-tos work and decompiling the loops. That's the thing that, I spent the next year trying to figure out how to do properly, and finally I kind of failed a little bit in many places, right? But basic decompilation, yeah, you can do that quite easily. And, after the meetup, I can show you the details of that, because that's another half an hour presentation that I wouldn't want to do. But it's a fun exercise. And some things, if you want to do it properly and very well, it is crazy difficult. And, this is my... Like some of the pieces of code that was, yeah?
Sorry, but there's another question from the live.
Okay. So just let me finish this, and then we'll go to that question. But talking about the difficulty, there are 2 algorithms in this decompiler that I still don't understand how they work. I just build them, and I kind of try to figure out, because it's like, how do you call it? Recurrention, and upon recurrention, upon that, and it's like a few levels deep, right? And you just cannot wrap your head around in how it works. But you can try to figure it out piece by piece and see that it works. So there are some absurdly difficult algorithms that are being used to achieve this kind of results. And yeah, the question from the computer.
From the live chat. Is there anything being worked on right now so you can write a contract in Solidity for Solana?
Ooh, yes, perhaps someone from the audience knows the answer. Yes.
On the Solana website, you can find there are 2 projects that deal with this exact issue. Yeah.
Cool. Okay, so we know the answer now. Thank you for that.
Just go to Solana, their website.
I'm like the Ethereum maximalist, so I don't care about the others. No, just kidding.
One of them is Neon. It's called Neon.
Yeah, there were many discussions about Solidity, readability, and optimization recently in the community, especially after OpenSea released their new versions of smart contracts with, I guess, assembly code inside of Solidity, if I remember correctly. And what do you think about it? And I want to ask a question: if you think is Viper is a solution, or it's a better way to develop?
So for me, I hate curly brackets. So any language with curly brackets, that's like I would hope for it to die, right? And that's the quick answer. But the sad reality is that we're stuck with Solidity, whether we like it or not, because of the whole network effect. So I'm I'm cheering all the efforts to make it a better language, and I think that's the way to go. Although I still cheer for Viper and all the other languages to succeed, but it's probably a losing battle. But still, I would love them to win. It just I don't think they will. As for Solidity, I remember they at least they were, and I'm sure they are improving. There were some methods being tried to do even formal verification within the Solidity code. So it's getting better, and it's an amazing field of research and active development and whatnot. So yeah, like all the best to them. There was a question over there. Someone was asking, no? Oh yeah, you forgot.
Yes, a question for you, Tomek. Thank you for the excellent talk. I was wondering, do you recommend that all companies that are writing Solidity code, that before they release their code, that they go through that process of decompiling it and then looking at the decompiled results?
For two reasons, yes. First of all, okay, again, the decompiler wasn't maintained for the last 2 years, and I know that it fails on some contracts. So some contracts it won't handle well. And here is the first reason. If it doesn't handle your contract well, it probably will not also, your contract may not be handled well by formal analysis tool. It will be harder to formally prove the contract. And you can see that difference. For example, if you look at the maker contract, at least the last time I looked, it was super nicely analyzed by the decompiler because they were thinking about formal analysis and that kind of safety from the day one, right? So it should tell you something if the decompiler breaks on your smart contract from that perspective, right? If it manages to decompile it, 100% yes. I think like you should do that as an additional step of the software audit because you can really see things that you wouldn't be able to see another way. And yeah, I think so. Yeah. Okay, I guess slowly we're running out of time, but I guess two more questions.
Hello. How did you store the code in the database, in the BigQuery database? Was it something like a Lisp-like structure, AST, or just simple Python text?
Okay, so the question is, how did I store it in the BigQuery? Like basic level, JSON, right? But that doesn't tell you anything. The output from the decompiler, there are two kinds of output. One is human readable, so it has all the loops and everything, and it's very nice, right? But there is other output that is very similar to the first one that looks a little bit like Lisp notation. And if anyone mentions Lisp language, like some people run away, from the room and the night birds come back. But Lisp is also quite an awesome language. So now the whole contract it's not an AST tree, I would say, but it's just a language that is very easy to convert into a tree structure. But it's not an AST because AST, okay, I can talk about that more, during the break. But AST is not actually, I think, the best way to analyze it. You can have a form that is even easier and better to analyze, and that's what the decompiler provides. So now that form, is a tree with leaves as and that's in a JSON form, and the JSON form is in the BigQuery database. So you can, if it's in a JSON form, it's easy to parse using JavaScript, and that's why you can do searches on it, because it's very it's native, it's within the whole JavaScript JSON thing. So I hope that answers the question a little bit, but it's a complicated subject, so I'm happy to talk about it during the break.
I'll approach you afterwards.
Yeah. All right, 1 or 2 more questions. All right, here, a friendly person at front.
Okay, I have maybe more general question. So, is there any way or idea to make your product unnecessary, in the sense that is there an option to force users, coders, to make the code public?
So I would say writing the decompiler taught me one thing, that actually the virtual machine underneath the whole protocol matters. And depending on how you design the virtual machine that is underneath, you might not need a decompiler. Or even better, if you design it better, sometimes you will not have certain kinds of bugs that exist otherwise. So if Ethereum was using a different virtual machine, then you could just open up the source code, do a very easy conversion from bytes into the source, and you would see the source very clearly. And actually, if the virtual machine had a few different tiny tweaks, I wouldn't spend a year and a half building a decompiler. I would spend 2 weeks to do that, right? And that is the thing. And I know that Ethereum is switching to how do you call it, the new virtual machine. It still has the same issues, slightly better, but it still has the same issues. So I would say if the virtual machine changed, yeah, that would be possible. And actually, there were some protocols that had different virtual machines that actually were better for formal verification and all that kind of analysis. I don't remember the names of the protocols, but yeah, like writing the decompiler taught me that yeah, it wasn't bullshit. Like you can really have a better protocol. Still, Ethereum has network effect, so long live Ethereum. But yeah. All right, one more question, and thanks for that one. Or is it?
Anyone?
Oh, no more questions.
No,
all right.
One more question.
So, like once we are in the topic on this EVMs, so like the differences you were mentioning right now, do they can different implementations of EVM on different blockchains like force some kind of bugs or like allow some kind of bugs and others, no?
I think so too. Yeah, I think absolutely. I don't know that for a fact that someone made some kind of bugs, but to give you an example of what almost broke one of the updates of the Ethereum network was that they changed the price of one operation, and they changed it slightly to slightly lower price, and that allowed certain kinds of exploit to being done. And in theory, it could break a lot of contracts because some of them use that assumption about the price internally, some of the contracts, to verify certain conditions. I don't want to go into details, but again, during the break, I can tell you. But the thing is, it's not like the developers were fancy. It was one of the libraries made that assumption that this thing is possible, this not, because the price of this operation is this and whatnot. So, if in theory, like this could break a lot of contracts without developers being aware that their contract actually gets changed by the implementation of virtual machine. And that was a very benign change, everyone thought. It was just, changing the price. What bad could happen, right? But some bad things could happen. And that's why the Constantinople fork had to be delayed, because someone realized that things could happen a week before the release into production, right? So it was after all these tests and whatnot, someone said, hey, what about this? And then, the community had to figure out what to do a week before premiere, and they had to delay the premiere. So if that thing could happen, I'm sure there is at least one blockchain that has some kind of flows that are exploitable through this way. I don't know for sure, but with like thousands and tens of thousands of blockchain right now, I guess, like some of them will actually have this kind of problems. Yeah. All right. Thanks a lot. And, we can talk during the break after the second speech, which will be Yeah, where is the second speaker? Or do you want the
here.
floor?
Thank you, Tomek, for
Thank
this
you.
amazing presentation. Yeah. Thank you, Tomek. And now please welcome Rafael Cosman.
Hello, hello. Can you hear me all right? All right. How's everyone doing tonight? Good. So kind of quiet crowd today. It's not a rave. It's not yet a rave. Maybe we can work on that. Give me 1 sec. Just going to project my slides here. Is this working? Not working. Not working yet. These are the tech issues that you have to have for any presentation. Oh, maybe I have to unify the displays. Okay, wait a sec. Oh no. Oh, I updated my OS, so now the menu looks different for changing the displays. This is terrible. Yeah.
And here main
Mirror. Yes, mirror. Mirror displays. Oh, we got it. Okay. Boom. Excellent. This did not show anything awkward. All right. Can everyone see what we are projecting here? Great. Okay. So it's kind of quiet crowd tonight. I hope folks are going to get engaged with this stuff. I'm Rafael Cosman. I am one of the co-founders and the CEO of Trust Token. Has anyone heard of Trust Token? Okay. All right. Decent number of people here have heard of Trust Token. Probably like 15 or 20 of the people in this room are actually colleagues of mine, which is great. I have the honor of working with Houston and many other folks. But I'm not here to talk too much about Trust Token. I'm here to talk about DeFi and stablecoins and lending. Very briefly, just my background and our company's background. We're a team of 95 people globally. We run $1 billion stablecoin called TrueUSD. We also run a DeFi protocol called TrueFi that does on-chain, uncollateralized lending. I think just past $1.6 billion of loans originated. So we do a lot of stuff in the DeFi world. And I'm here to tell you a bit about what's going on with DeFi, what we're excited about there, and what's going to be happening over the next couple of years. But let me start by asking, how many folks here already work in crypto in some way? Okay, that's decent. So maybe half of them. How many people here do not work in crypto but are interested in potentially getting into it? Okay, some folks. Great. Okay. So, and for the folks that work in crypto, how many people work in DeFi specifically? Okay, not as many. Good. All right. So this talk is primarily about DeFi, decentralized finance, and why it is one of the most exciting areas of all of crypto. It's one of the biggest things that's going on Ethereum these days. Why I personally think that if there's anywhere that you're going to invest your time and your money, I think DeFi is the spot. NFTs are cool. New people making new L1s, that's cool too. I think DeFi is the spot, the most exciting application of crypto. I'm going to explain why. What DeFi is essentially doing is rebuilding finance in a more transparent and trustworthy way. So if you've ever used a DeFi protocol like Compound or Aave or many others that we're going to talk about shortly, you've probably seen these are financial applications where you can literally go read the code, and if they're doing loans, for example, you can see every single loan that they've ever made. It's completely transparent on the blockchain what these protocols are doing, which is a very unique property. There's nothing that we've seen in finance, in the entire history of global finance. There's nothing that we've seen with a similar level of openness and transparency. So for comparison, think about your bank. So what banks, I'm from the United States. I just flew in yesterday from California, so I'm a little bit jet lagged. But what bank do you all bank with here in Poland? Can someone shout? What bank do you bank with? Your bank. What bank do you work with? Millennium? Santander? Okay. So you put your money with Santander, right? How much do you make on your checking account or your savings account with Santander right now? Zero or minus, right? Is that true? Are most of you making 0 or minus in their bank account? Most of us. Okay, most of us are making 0 or minus in our bank account. Now, those banks are making loans with your money, right? Okay, when they make loans, are they loaning money at 0 or minus? No, they charge 10 times, right? They're definitely not loaning. When I get a loan from my bank, they're not loaning me money at 0%. No way. They're just paying us 0%. So what's going on there? So they're loaning out money at a much better rate, but we don't have any visibility into what they're doing. I don't know what loans Santander is making if I bank with Santander. They're making whatever loans they want. They don't disclose that to me. And not only that, not only do I not have transparency into those loans, but what fraction of that interest am I actually making? They're probably lending to people who want to buy houses, whatever they're buying, at 2%, 3%, 4%, 5%, right? The fraction of that I'm getting as someone who puts my money into Santander is almost 0. I'm getting almost 0 of the profit that they're making with the money. So it's not that they're not making money with your money. It's just that you're not getting the money that they're making. It's the people at Santander are making the money. The stockholders of Santander are making the money. And there's nothing wrong with that. They're running a business, but that's just the state of the banking market today. It's not that Santander is a bad bank. You go over to Millennium, you go to Wells Fargo that I bank with in California in the United States, it's the same thing. It's the same thing everywhere you go. All the banks are giving out loans. They're making a bunch of money on those loans. It's just not going back to you and me, the people that put our money into the bank. Am I right? Is that fair? Okay, so that's the state of where finance is today. And if you look across many different areas of finance, it's the same thing where the end consumers do not have the negotiating power to end up with a large share of the economics. We have very little negotiating power in this game with the banks, and that's why we end up with almost no economics. If you were a hedge fund with $100 million under management, your relationship with the bank would be very different. If you had some money that you were not trading and you wanted to put in the bank to make some money, they would be offering you a very different rate than what we as consumers are getting. It would be much closer to what the bank is actually making. The bank is always going to make money, but if you're a $100 million hedge fund, or if you're Bill Gates with his billions of dollars, you can negotiate with the banks. You have a lot more leverage. You can end up with a much larger share of the economics. Part of the issue with finance today is that as users, we don't have very much say. We just don't have the negotiating power to end up with much economics in these things. So that's part of why DeFi is exciting. Is everyone following so far? Good? Okay. So there's also the transparency piece that we didn't talk much about. But when you have your money at the bank, you don't have any visibility into what they're doing with it. And everyone knows the banks, they oftentimes have these big impressive buildings, right? Big columns outside and so on. That's partly because they need to project confidence and show you, hey, this is why you should trust us with your money, as opposed to you actually having transparency and seeing this is what the bank is doing with my money. This is why I should trust it. Okay, so that's a bit of background on why DeFi is particularly exciting, why it's impactful for the world. Two big areas within DeFi that I'm going to talk about today. One is stablecoins. Stablecoins are a very fundamental primitive for DeFi. You essentially can't have DeFi without stablecoins. It was in 2017 that the first major fiat-backed stablecoins came out and started to grow. And that's really what helped to enable all of decentralized finance to grow. Because there's not that many interesting things that you can do if you just have ETH and Bitcoin and a bunch of other highly correlated and highly volatile assets. It's when you have stable coins, essentially, tokenized versions of fiat assets or digital assets that are pegged to various fiat assets, that's when you get the most interesting applications in DeFi. So stablecoins are a really key building block within DeFi that we're going to talk about today. And then we're going to talk about protocols for lending and borrowing, which is another huge sector of DeFi. But there's a lot more DeFi beyond those topics. There's hours and hours that we could discuss about DeFi, lots of different areas, but we're going to focus on a couple of areas that are just areas, very fast growing, very major areas of DeFi, very important to understand. All right, so stable coins. So can anyone describe what is a stable coin and why would you be interested in using one? Yes, you have a microphone. You can speak into your mic right there. What's your name, by the way? Jacob, what is a stablecoin, and why is it interesting? Oh, there you
Maybe
go.
now you know. Okay, so it's very interesting thing. For example, taking a profits from.
Yes.
For example, you bought a Bitcoin for $10,000 and it's worth 50. So we want to cash it out. For example, in Poland, you don't pay taxes until you cash this to the fiat. So you take your profit in USDC or USDT, and that's one way to get it.
Exactly. Thank you, Jacob. So that's well said. So stablecoins, one of the many use cases of stablecoins is just to be able to take your profits from other assets. Like your Bitcoin or your Ethereum goes up 10x, you might want to sell some of it, put it into stablecoin. And you might do that as an intermediary step before moving it into your bank account in fiat currency, or you might just leave it in stablecoin because you want to reinvest it in crypto later, because you want to use it in other DeFi protocols, but it's a much more stable asset to hold than just keeping your money in Bitcoin or Ethereum, and you still get a lot of the advantages of crypto. So in addition to those kinds of taking profits, people also use stablecoins for payments. Like a lot of trading firms, for example, will send, multi-million-dollar stablecoin payments to other trading firms. People can send stablecoins in small amounts to each other. Sometimes that doesn't make sense because of gas fees. If I'm going to send you $2 of stablecoins and pay 15 cents in gas, it might not make sense. But that's something that people are working on from a technical standpoint. Our slides okay? Okay, so a lot of different applications why people use stablecoins. Today, the stablecoin industry is well upwards of $100 billion in total across many different kinds of stablecoins. Different approaches to this core problem of how do you make a price-stable cryptocurrency? A price-stable cryptocurrency so that people can use that in DeFi, can use that for payments, can use that to take profits. A lot of the reasons why you might want to hold the Polish zloty or the US dollar, people want a digital version of the same thing. So a couple different solutions to this problem that folks have come up with. One, fiat-backed stablecoins. These are in some sense the simplest and least risky kinds of stablecoins, but they also are many times the most centralized. So has anyone here used one of these products, TrueUSD or USDC or another one of the fiat-backed stablecoins? Yes, okay. So the way these work is pretty straightforward. Someone has a bank account. You send in a wire of, let's say, 100,000 US dollars, and they will mint for you 100,000 of the stablecoin. And vice versa, you could send in stablecoin. You send in, let's say, 5,000 stablecoin. They'll send you $5,000. Usually these are US dollars, but there are stable coins for other foreign currencies as well. To my knowledge, I haven't seen a Polish zloty yet. There are some euro ones, but there are probably going to be more and more stable coins over time, just tokenized versions of different assets. So that's fiat-backed stable coins. Then there's crypto-backed stable coins, things like UST. I assume folks have heard of UST and the recent disaster that happened there. So that model says we're going to have a cryptocurrency that's going to back a stable coin. This model is extremely risky, can be the most decentralized, but has some major issues. Major issues. And specifically, if you back a stablecoin with only highly volatile cryptocurrency assets, then if those assets go down, you can end up in very big trouble where your stablecoin isn't stable. So if we just take a look at some of these stablecoins recently on CoinGecko, just for comparison, so you can see here's USDC, right? One of the major stablecoins today, something like, I think, $50 billion in this stablecoin. Let's see what it says. Yeah, $55 billion. And you can see very stable over time, right? Because this is, as I described, it's fiat-backed, redeemable 1-for-1 with US dollars, very stable over time. TrueUSD, another major fiat-backed stablecoin, very stable over time. Something like Terra, which I think folks have heard about, that is the crypto-backed stablecoin that recently fell off a cliff. You can see it was worth $1 up until recently, and then it was worth almost nothing. And the way that this stablecoin was designed is it was backed by a volatile coin called Terra, where you can redeem the stablecoin for $1 of Terra. The fundamental issue with this design is that it creates a feedback loop where if people start redeeming the stablecoin for Terra, because you take the $1 of stablecoin, you redeem it for $1 of Terra, you sell $1 of Luna, you sell the Luna, and get cash, that's fine, but then the price of Luna has gone down. You keep doing that with more and more Luna, and the price of Luna, of course, is going to crash. It's going to accelerate, because the lower the value of Luna goes, the more Luna you're going to get when you redeem your stablecoin. So very fundamental issue here if you try to back a stablecoin with just this kind of highly volatile cryptocurrency asset. So a very interesting approach that some folks have taken is backing stablecoins with a mix of different assets. And this is actually what DAI, which is here on the middle of my chart, has done. DAI and Frax are two major stablecoins that take this mixed approach, where DAI is actually backed by a whole bunch of different assets, some Ethereum, wrapped Bitcoin, other stablecoins, including USDC, and many others, a whole variety of different assets. And the way it works is you can go take, let's say, $150 of Ethereum, and you can lock it up with the Maker protocol and mint $100 of DAI. Now, this avoids some of the issues that a completely crypto-backed stablecoin like UST has. First of all, because they're using a variety of assets, and so any one of those assets depreciating in price is, assuming that they're well enough diversified, the overall Maker system, the overall system behind DAI can still work well. But second of all, they have very strong over-collateralization. So you can't lock up $100 of Ether and create $100 of DAI. You have to lock up $150 of Ether to create $100 of DAI. Oh, I think we just... Okay, it's back. So it's over-collateralized, and so there's a certain amount of a drop in the prices of any of those assets that the system can still tolerate and not implode. So when we look at the performance of these things, they tend not to be quite as stable over time as some of the fiat-backed stablecoins, but still seem to be doing overall quite well. So if you look at this historical price of DAI, you'll see that there are significant periods of time where DAI stays at like $1.02 or $1.03, where the fiat-backed stablecoins tend not to do that, because the fiat-backed stablecoins can be more easily arbitraged. Like the moment a fiat-backed stablecoin is trading at $1.01, someone is incentivized to take $1 of cash, mint the stablecoin, and sell it into the market. Or vice versa, if it's trading at 99 cents, someone's incentivized to buy the stablecoin, redeem it for $1 of cash, and they've pocketed a 1% profit. So the fiat-backed stablecoins tend to get arbed more quickly back to $1. These kinds of crypto-backed stablecoins or mixed stablecoins like DAI or Frax are more likely to stay away from $1 for a longer period of time, because let's say if it's trading at above $1, you'd have to lock up $1.50 of Ethereum to go mint the dollar of stablecoin and then sell into the market. And so it's a little bit of a more difficult process, and it's less clear that it makes economic sense depending on exactly what's happening with Ethereum at the time. Does that make sense overall, the breakdown of stablecoins, different approaches? Cool. Any quick questions on that? Thoughts that folks have? Yes? If you don't have a microphone, you're going to have to speak very loudly. Yes?
I think it's a little bit misleading to picture Terra UST as a primary crypto-backed stablecoin, because really the issue was that it's algorithmic, right? Like you can have purely crypto-backed stablecoin like RAI, which is like its value, it's purely function of like a leverage demand on the market, and it still like works, holds a peg, right? Like with UST, it was the problem with the whole economy and the algorithmic, exploding supply and so on. So
it is total. What's your name, by the way?
Chris. We met in
Chris.
Denver.
Excellent. Okay. Good to see you again, Chris. Chris, I think that's totally fair, and I agree. I don't mean I think you're right. This slide may be a little bit misleading, because I don't mean to give like the completely crypto-backed stablecoins a bad name because of what happened with UST. I do think that there's a fundamental issue with the crypto-backed stablecoins, that oftentimes they are higher risk than some of the stablecoins like the fiat-backed ones, higher risk, but they don't give holders of the stablecoin a corresponding reward. These stablecoins, my recommendation to crypto founders that are or people that are starting projects who are designing stablecoins like this, either algorithmic or crypto-backed stablecoins, like some of the ones that Chris described, is think about them potentially more like a bond where you're actually going to pay a yield to holders of that stablecoin over time that corresponds to the risk that they are taking. Because I think it's a fundamental issue if you have riskier stablecoins, it's backed by a riskier asset, but you're not paying users to accept that risk. In that situation, I think it might be just smarter for those users to use something that really is backed by US dollars and doesn't have that risk. But I do agree with you, Chris. There are good ways to design these very crypto-backed or even algorithmic stablecoins. It is just it's a more challenging problem, and it's a very active area of research. So I'm not at all proposing that we rule out those possibilities. And if that is something that you're interested in working in, I do think there's a lot of very interesting stuff to be done there. It just needs to be done very thoughtfully, very carefully, and possibly paying a significant reward to the holders of those stable coins so that they're really compensated for any risks that they're taking. Yes, one more question on stable coins, and then we're going to move on to lending.
Yes, my question is about which one exactly is a great example of stable coin, algorithmic stable coin, because like UST is a disaster, everybody knows that. But next, for example, Waves got a problem with the stable coin even before UST. Now I heard that Justin Sun is doing his USDN.
Yeah,
USD.
Justin Sun's USDD is having some issues too.
USDD, yes. So USDN is from Waves. It was before. So I don't really see a good example of working this correctly, because UST was working correctly in the bull market, but when it comes to the opposite, then it crashed. And
exactly. So I think that today this sector, the fully crypto back or algorithmic stablecoins, I think it's too early to say that there's really strong examples there of who's doing it well and in a sustainable way. I personally think if you had to invest somewhere today, I think these two areas are probably safer. And I think this area in the middle, like what DAI and Frax are doing, what Maker and Frax are doing, I think that's a really interesting intersection where it gets some of the security and stability of a fiat-backed stablecoin, but with more decentralization. So I think that's a really interesting area. And I think this area just needs more work and more development. And right now we're in a very early stage where we're seeing projects like UST, like USDD, having their issues. And that's a necessary part of seeing if we can emerge from this with some really strong market leaders. So I think too early to say. If you can pick them and figure out which ones are going to be big in the future and go invest, you could potentially make a lot of money. Okay, so very lively discussion about stablecoins. Would love to take more questions and discussion about it afterwards, but for now I wanted to move on briefly to the very related topic of lending in DeFi. So lending. So one of the things that you want to do when you're rebuilding all of finance in DeFi in a more transparent way is be able to lend and borrow on chain. And why is this important? We just had a great example of why this is important just a few days ago, June 3rd. So that's literally 8 days ago. Celsius, a major lender in the crypto space. They make a consumer app. I don't know if anyone here uses it. You can put in stablecoin, you can put in Ethereum, you can make 6, 8, 10% on your holdings there. They pay them out daily. Super cool app. They just had a major issue, and they literally blocked withdrawals. There's billions of dollars of user deposits that stuck in Celsius. And right now, that's part of what's causing the whole shitstorm in crypto right now, is this huge lender and a couple of other major firms that are potentially imploding. So folks are familiar with this? Some of what's going on here? Yes? Okay. So major issue. Now, Celsius is not a DeFi protocol. They're an app. They're what we call CeFi, centralized finance. And part of the issue with CeFi is you don't have transparency as a user into what they're doing. The beauty of DeFi is you have that complete transparency. With something like Celsius, you put your money in the app. You trust, because they've got a good brand and because a lot of other people trust them, you trust that they're going to do a good job with your money. But then when they don't, it kind of sucks. And you had no transparency. You had no idea what kind of loans they were making, what the status of those loans was. And up until the moment that they announced that they're pausing withdrawals for their app because they might be insolvent, up until that moment, no one, unless you work there, has that level of visibility into what they're doing. So that is the beauty and the power of DeFi. That is why DeFi is so important, is that with a DeFi protocol, you can, in pretty much all situations, you can see on-chain exactly what that protocol is doing, exactly how it's using your money, what the code says about how it's going to be using your money in the future, and you know what's going on under the hood. So DeFi protocols, they still break all the time. There's still hacks, there's still issues, there's still loans that go bad, all kinds of issues with DeFi protocols, but it is fundamentally more transparent than the way that CeFi works, and that's part of the potential here. So there are several major areas within DeFi lending. It breaks down two big categories: over-collateralized lending, which includes Compound and Aave and Maker, the stablecoin that we just described earlier that you have to put up 150% collateral with. And these over-collateralized protocols, they all work in a similar way, which is you take a bunch of crypto assets, which could be Ethereum, it could be a stablecoin. You take a bunch of crypto assets, you lock it up with a protocol, and then you get to borrow a different asset, but you can never borrow as much as you locked up. So they're all over-collateralized, and that's what protects the protocol against defaults. So anyone here could be a borrower from any of these DeFi protocols. The catch is just that they take, oftentimes 120 or 150% collateral, and so that's how they don't have to do any sort of credit assessment. There's now a new sector that has emerged in the DeFi world, and actually one of my company's products is in this area, which is the and under collateralized lending. And this is it's a new and hot and very fast growing area, which is basically about how can we have people be able to borrow from a DeFi protocol, just like how you could go borrow from the bank or from another lender, but not have to put up, let's say, 150% collateral. And this oftentimes leads to, if it can be done well, much more attractive rates for lenders, because you're taking on somewhat more risk when you lend to someone without collateral, but they're also of course willing to pay a lot more. It's not efficient for a large trading firm like Alameda, let's say. It's not efficient for them economically to have to lock up, $1.5 million of ETH if they want to borrow $1 million of stablecoin. It's very efficient if they can borrow $1 million of stablecoin without having to lock up any collateral. And so they're just willing to pay a much higher rate for that type of borrow. Does that make sense at a high level? Cool. So looking through a couple of these protocols, some folks here may have seen these, may have not. So this is Compound, one of the first DeFi protocols that emerged, really defining for the entire DeFi sector. They do over-collateralized lending. You can see here, not great rates on stablecoins right now, 0.23%. Some of these like Tether are higher. But these are doing over-collateralized lending, and so it's pretty low risk in that Compound is holding oftentimes 120% or 150% collateral for every dollar that they loan out. So you can take your stablecoins, other assets, put them with Compound, and know that it's doing this pretty reasonable type of lending with them. And also, if you compare this to what's going on in TradFi, we just talked about Santander, right? Santander is doing loans at oftentimes 4, 5, 6%. You get almost nothing. Compound, you can literally see in the code, they give something like 80% or more of all of the interest that's made from your money goes right back to the users, the depositors of that money. So that's a great deal. You know that you're actually getting compensated for all the risk that you're taking, and it's not like the protocol or some other intermediary is pocketing a huge chunk of that profit. So Aave, another very similar protocol. You can see here, large amounts, about $5 billion, say almost $6 billion in one of their major markets on Aave. So very, very significant protocol, doing loans at very large size. And you can see here pretty reasonable rates, oftentimes, around a little under 1% right now for stable coins. I think we're in a pretty depressed market today. Crypto's down, all the lending rates are massively down, but oftentimes you'll see here, 2-3% for many of these stable coins. In the uncollateralized lending space, my company's product is called TrueFi, and you can see here, oftentimes rates that are in the 10%, 9% kind of range. This is higher because, of course, you're taking on somewhat more risk when you do uncollateralized lending. And really, where we see DeFi going is offering a whole suite of different products to people with different points along the risk return curve. So everything from, a super secure 1% or 0.5% all the way up to a much more aggressive 8, 9, 10 or even higher percent. So, we think that there's a suite of products that's being assembled in DeFi with altogether, very attractive risk returns and all the different things that you might want that formerly you had to go to TradFi to get. I see some questions. So actually, I'm going to briefly conclude, and then we'll have time for question and discussion. Okay, so that's most of the content I wanted to share today. This kind of a high-level overview of stablecoins, why they're exciting, why they're important, what the different kinds of stablecoins are, and some of the trade-offs, what's going on in DeFi with over-collateralized and under-collateralized lending, and where we see DeFi going as really establishing this more transparent alternative to everything that's been happening in finance so far. So if you are a builder in the space, I think that there are a ton of opportunities here. There's a lot more things to be done with lending. There's a lot more interesting innovation to be done in the stablecoin area. You can actually just go look at what's going on in TradFi and in FinTech, and then look at what's missing in DeFi, and there's tons of things missing, and just pick one and build it. And I think there's a lot of great companies and a lot of great projects to be started. So I would love to talk with anyone here if you have ideas or things that you're excited about or want to get feedback on. Would love to talk about that, figure out what we can build. And I think we do have a hackathon that ETHWarsaw is going to be hosting with some prizes that our company and many others are going to be sponsoring. And so if you do have ideas for things you want to build in DeFi, please come to the hackathon and get some of them built and shipped. Okay, so with that, I'm Rafael Cosman. Thank you for your time and for your attention. And I would love to open up the floor for any discussion or questions. Yes, and can you say your name when you ask a question as well?
Hi, my name is Arthur. Nice to meet you. And one of the quirks of the Ethereum is trustless. And my question is, how is TrueFi is not fearing that user will borrow some money uncollateralized, for example, and just run from it because it's just an address on the Ethereum. In the other collateralized, you have to put something to borrow.
Yeah, very good question, Arthur. So the question is essentially, how can you do uncollateralized lending? And let me talk about uncollateralized lending in general, because I don't want to pitch my product. This isn't the place. Or I'd be happy to pitch my product, but not tonight. How do you do uncollateralized lending on Ethereum if Ethereum is about being trustless? And Arthur, my answer to that is what a lot of these protocols are doing is the core protocol is completely decentralized, or actually some of these protocols are more centralized, some of these protocols are decentralized. TrueFi at least is decentralized, but there are different lending pools that are built on top of the protocol by different people that have varying levels of centralization. So some of those pools could be launched by an individual firm that is making those underwriting decisions and evaluating borrowers for creditworthiness. Some of those pools actually could be just controlled by a DAO and have people voting using a token to govern what loans they want to make. So there's a variety of different lending strategies that you can explore within this that have different levels of decentralization, but that can all still be done in the context of an open protocol. So you can think of it as sort of a mix of DeFi and CeFi, or like a DeFi platform for people to build potentially centralized pools on top of.
Yeah, thank you. And also one question, what do you think about future with soul-bound tokens and maybe on or under collateralized?
Soul-bound tokens?
Yeah,
I don't know what those are.
Okay. That's a thing that Vitalik Buterin told about. It's like a NFT, but non-transferable, that you can give some parameters like you are a good person, for example. I don't know. blockchain reputation.
Yes, so I think blockchain reputation it's a really important area. No one's really cracked it yet, but a lot of people are working on it, and I think that can really feed into what a lot of these uncollateralized or under collateralized lending protocols are doing, and allowing people to establish on-chain credit history and on-chain credit scores that can then be lent against. So there's a lot of work that needs to get done there to really be able to expand the kinds of lending that DeFi can do. So absolutely. Thank you, Arthur.
Thank you too.
Other questions? I do want to ask, let's not do follow-up questions just because I want people to have an opportunity to get a variety of folks to ask questions. Go ahead.
I would like to ask, how do we approach KYC of depositors in your platform? Is it requirement or what's the status right now?
Yeah, so many of these protocols take different approaches to KYC. The protocol that my company has developed, TrueFi, supports pools that require KYC, and it also supports pools that do not require KYC. And there's a mix of both on the protocol. So I think that the future of DeFi is going to have a mix of KYC'd pools of capital and un-KYC'd pools of capital, and they're going to be used for different things. Some borrowers might want to say, hey, I only want to borrow from a pool where all the money has been KYC'd. Other borrowers might say, hey, I don't care. I'm happy to borrow from this non-KYC'd pool if I get a better rate. So that's where we see KYC going in DeFi. And there are even some of the over-collateralized protocols like Compound and Aave are actually developing essentially KYC pools of capital within them. Aave has Aave Arc, Compound has Compound Treasury, and many of these are sort of, subsets, subsets of the overall protocol assets that can be more KYC than the rest. Yes. Thank you. Yes, in the back in the orange shirt. Okay.
Hi, my name is Lucas. Do you know Alchemix protocol? And if so, what do you think about it?
Oh, I only know the tiniest bit about Alchemix protocol, and so I can't speak to it, unfortunately. Yes.
Hey, my name is Vladislav. I guess my question is a little bit of a follow-up on the question before the last question, and it is... what kind of government regulation, if any, do you think is welcome in DeFi? Do you think that bank-like regulations, guarantees on deposits would be welcome in the community or not? What are your thoughts on that? Thank you.
Great question. So it's Vladislav?
Vladislav, Vlado for short. Vladislav.
Vladislav, okay. Yeah. I'm American, and so I'm still working on some of the Polish names. Vladislav. So the question was about what kinds of regulations are welcome in DeFi. That's a great question. There's a lot to be said there. There's sort of what kind of regulations does the DeFi industry and do we as members of the Ethereum community want, and then there's what's actually going to happen. And I think that what's actually going to happen is regulators are probably going to try to impose a lot of the regulation that's been developed for banks and for other traditional financial institutions to DeFi, and I think it's going to have mixed results. And one of the things that's interesting and powerful about DeFi is that you can, a group of completely anonymous developers could launch a DeFi protocol that doesn't care about the law at all. And it's very difficult for regulators to be able to regulate that effectively in any way. They could try to make it illegal and say, hey, you'd be breaking the law if you use this thing, but that's not necessarily going to stop people from using it. So some of DeFi may end up unregulatable regardless of what the regulators want. I think that a lot of DeFi, though, is going to choose to abide by regulations, as our company and many other companies are working on. And, it's going to include having KYC pools of capital. It's going to include making sure that all lenders or investors know what risks they're taking and have transparency about where their funds are going. And right now, there just isn't clarity on a lot of what you have to do to be compliant as a DeFi protocol. And so to a certain extent, what you do is just hire really good attorneys and have them come up with the best possible application of current laws to what we're doing today. And then as regulators actually come out with more specific laws about what they want to see from DeFi, then you got to abide by those. So I don't think it's a great situation right now. I think that there are a lot of issues with how current regulation works and how it gets applied to DeFi. But I think that part of what we need is more education and more engagement between the DeFi community and regulators to help figure these things out and come up with regulations that actually do make sense. Okay, I'm gonna take 2 more questions and then I'm gonna wrap up. So, go for it.
Спасибо. Thanks for your presentation. My name is Alexander Kvaskov, and on your first slide, you talk about stablecoins, borrow and lending, but not about liquidity. And I think that liquidity is
Yes.
important things in DeFi, and maybe you hear about project Lido. They yes, cool, very cool.
I do talk about liquidity. So, yeah.
They make Ethereum in Beacon chain.
Yeah.
More liquidity, and you can transfer ST, ETH, and it was stable coin when ETH cost ETH, ST, ETH. But right now, ST, ETH not cost ETH with discount. What do you think about it?
Yeah, that's been a major issue for some of these firms, like Celsius and some others, folks that were left holding STF with Lido, and then it ended up significantly depegging from ETH. So it's an interesting, Lido is an interesting protocol, and it seems like right now its future is uncertain. And this issue with STF is a very, very big question for Lido and for the Lido community. So I don't know enough about it to say which way it's going to go. But hopefully, if everything works well, then eventually STF should be able to repeg to Ether. So because it is ultimately I think you still have the Ether. It's just sort of a locking and liquidity issue. But I agree in general that liquidity on assets is a huge area within DeFi, and lots of interesting protocols and work being done there. So.
Okay, thanks.
All right, one last question.
Hey, I just wanted to address this.
Yeah, go for it.
So ETH was never pegged to ETH. There was always kind of a risk factor when it comes to contracts that and the whole infrastructure that is being made. So it never was one-to-one, and it's okay, it is not. And ultimately, the STATH will be redeemable for ETH when the ETH will be unlocked. Not after the merge, but let's say half a year or year later, let's see. So it's a completely different situation than with Celsius or other protocols.
That's right. There's this time issue there, which is that you have to wait something like a year before it gets unlocked. So in the interim, you could be somewhat unhappy, but if you wait long enough, you should be fine, as long as that there's no issue with the underlying ETH that they're holding. So you can see here what we're describing. So it was, while it's not guaranteed to be at 1 ETH, it was for quite a while trading at 1 ETH, as you see here in red. This is the price of an ST ETH in terms of ETH is shown here in red, and then up until beginning of May, so quite recently, and then it's been trading at a significant discount to ETH. And so if you want to have an ETH in a year, you can go buy some ST ETH, and then in a year or so, you should hopefully get your ETH. But if not, then if there's an issue, then of course you won't. But assuming the protocol is working well, then this could be a reasonable purchase if you want to have ETH in a year. Okay, one last question from the gentleman in red in the back.
Here.
Thank you for your presentation. Definitely DeFi is an exciting space. I just wanted to make sure that I understood how TrueFi works exactly. So essentially, what you yourself, you are not lending any assets to people, but you provide protocol that other firms or people using that protocol, they can deploy their own liquidity pools. They do need to provide their own liquidity, and essentially they are gatekeepers allowing certain people on certain conditions to borrow this money. And on top of that, I'm guessing you have some kind of fee or spread that you may that you make your revenue with, or how does it work?
That's exactly right, and that's a great description of TrueFi. What's your name, by the way?
I'm Camille.
Camille. Okay, Camille, that's exactly right. It's a protocol that allows people to launch lending pools with a variety of different rules. And it does include some very large lending pools that are run by the protocol itself, by the DAO, and ultimately are governed by holders of the protocol governance token. But it also includes pools that are run, what we call third-party pools or independent pools, that are run by all kinds of different asset managers, and they get to act as gatekeepers, exactly right, deciding who gets to borrow from those pools. And there are also pools with different lender restrictions. Some of the pools, like the ones that are run by the DAO, by the community, they allow anyone to lend into those pools and earn a return. And some pools that are more gated, they may only allow KYC or a more limited set of lenders to come in. So think of it as a generalized protocol for being able to launch lending pools, and those lending pools could be completely open or much more closed.
Thank you for the answer. I do remember that you mentioned that you are fully decentralized, but if you also run your own lending pools, does it mean that you require some kind of credit check or KYC, or do you only mean decentralized as in your DAO?
Good question. So the protocol is decentralized, but has a variety of different lending pools that are sort of more or less decentralized on a pool-by-pool basis. And the pools that are run by the DAO do aim to be as decentralized as possible. The borrowers from those pools still today have to get KYC'd. And if there was a way to avoid that, or to use some sort of open source, on-chain KYC standard, we would be thrilled about that. Right now, it doesn't seem like that's possible. And so there's still, a lot of questions about how you can really do this kind of lending in a more fully decentralized way. So it's something that we're working on. Stuff like KYC, stuff like fiat on-ramp and off-ramp, it's not yet known how to do these things in a more decentralized way. So there are some places where protocols like these are having to make compromises today. But I do think that a lot of the most interesting stuff in general happens at these intersection points between DeFi and centralized finance, and there are interesting things to be done in like the completely full DeFi, like never touch KYC, not a single piece is centralized kind of way. But I think that is in some ways limited, and that this intersection point is complex and difficult, but offers a lot of opportunity.
Exciting stuff. Thank you.
Thank you. All right. Thank you for all of the questions. Thank you for your time. Once again, my name is Rafael. It was great to meet you all, and I'll be here for most of the night. So if you want to talk later, I would love to say hello. Thank you, and I will give it back to Justina.
Thank you, guys. Pizza is here, so please enjoy.